Okay, welcome to the Open Hardware Dev Room. We are fortunate to hear our next talk on an extremely interesting piece of open hardware here that implements a number of new ideas in how to provide useful single board computing devices. So please welcome John Thomson.
Hello, good afternoon, and thanks everyone for making it here. I appreciate it's after lunch on Sunday, and so it's been a long weekend. And it's been great to hear great talks on security, attestation, many different areas that lowRISC cover. One of the things that we're going to cover in this talk is about a bit of open source hardware that we've generated for a project. And also describe a little bit of what we do. And you may have heard of us through other means, so I'll try and explain some of that. So what is this talk about? So open source hardware and bitstream for evaluating CHERIoT. What is Sonata? So before further ado, this is the board. It's something that's been produced by our colleagues at New AE, a little demo stand as well. It's very swish now. And it's for experimenting with CHERIoT, and we'll get into what CHERIoT is. But firstly, a little detour. So what is lowRISC? lowRISC is a clue is in the name. RISC-V-based company. We were an spin out from Cambridge University. We celebrated our 10-year birthday last year. And our mission is to try and get Silicon Commons, so open source hardware. So when I was last in the room over there 14 years ago and giving a talk, I was on open source software. And now we're trying to do the same for open source hardware. So we're trying to make hardware the same as where open source software is now today. So what is lowRISC? So non-profit, so it's a CIC company, community interest company. We're not for profit. We have a full stack engineering team, so if you were in the RISC-V room yesterday, you would have heard about the Open Hardware Foundation. So our friends there who are also trying to get open source hardware. We do a lot more of the work in-house, but we also work on projects with other team members from different companies, which we'll show in one of our big projects. But we have all the way from LLVM, which was the basis of how lowRISC started. We went into, and we built up. So we've got RTL, we've got DV, we've got a lot of different types of engineers working with us. So we have about over 20 engineers. We have two main offices, two main sites. So we're headquartered in Cambridge. There's a picture of our office. And then we also have security researchers in Zurich. And we're expanding. We're always looking for people interested in open source hardware. And so if you're interested, please find me afterwards. We're a founding member of RISC-V Foundation, which is now RISC-V International. And also I'll be speaking a little bit about CHERI Alliance. And we're the steward and maintainer of OpenTitan. And we also inherited from ETH Zurich, the lowRISC project, which became IBEX. So we also maintain that 32-bit microcontroller. It's used in a lot of designs. This work was also done with our subsidiary, New AE. So we bought New AE a couple of years ago now. And New AE I've seen mentioned in many talks. So they work on investigating hardware side channel analysis, fault injection, but they work on security research onto hardware boards. And their product line, which you can see there, is Chip Whisperer. So that's one of their main products. So that's the CW340 board. They also work on the CW310. So I saw it mentioned yesterday, Chip Shouter. So if you're in security research, you may already have played with these guys' boards. Very talented people. Colin is a great chap, and so it's great to see references in other talks in different rooms. And then we also have the chip shelter. So this is a 3D probe for being able to do attacks on and be able to introduce probes for things here. And they also run lots of research. So you may see them at Black Hat if you go to them. So OpenTitan, so this is our big project. So what we do on this is a secure execution environment. This is a silicon root of trust, but it's open source. So I saw lots of talks this morning on bootloader, bootflow. You're all trusting on this TPM device. It's kind of like, oh, it's the magic hardware. How can you really trust that? We do, we've opened the design, so it's all the RTLs there, all the DV, and basically we're trying to go from, if the microphone still picks up, we're trying to go from on this left-hand side, which is the sort of state-of-the-art, which is, everything's red, not open. We're trying to get somewhere to everything green on the right. So we're trying to work with people, open synthesis flows. We're trying to make everything as open as possible. And so that's great. We can say it's on an FPGA. We can say it's been tested. But we've got quite big partners here in this space. So how can we prove this? Proof is in the actual chip. So we have thank you. We have an engineering sample chip, so that. We have real chips. So that was taped out, and we've been working with this to make sure that it's ready for production. So, okay, engineering sample chip. That's good. Some people get to that point. How is this good? The great thing is this is going into Chromebooks. So if you have a Chromebook, as of next year, hopefully, fingers crossed, we will have an open source hardware secure execution environment in the heart of Chromebook, so which is great news. Oh, sorry. Right. Okay, perfect. Sorry, there's a microphone range zone. Just here. Oh, the camera. Right. I will try not to deviate too far. Right. So yeah, so excited I'm moving stage left, stage right. So this is by our product partners. So we have on the project side, we work on the open source design, and then on the product side we have partners that you can see, well, Nuvoton and Google taping this out. So we're very excited. So that's our security background. So there's lots of interest in that. How else can we show this? Loads of commits. If you've worked on security projects, you'll have seen. This is the design people test against. So this is really active. Lots of people testing this. We're out in CHERS end of last year, hosted by NewA. Lots of them. It's real. DV. People are experimenting with it. So all of that is to say, come back to what this board is about. So we've got a background with lowRISC and UAE, and we were approached by Digital Security by Design to work on a project. So back to the content. So, as I said, we were approached by DSBD, which is part of CHERI, and there's been a long-standing thing to try and get CHERI and CHERIoT into the mainstream. This is something that's been here for about 15 years, so there's been a research topic for quite a while. But what is CHERI? What is CHERIoT? So we have to motivate this. So why are we interested in these ideas? So why produce these boards? So there's security breaches. What is interesting about security? You don't sell security. When you bought your hardware for Christmas last year, did you say, well, it's got the newest security feature? Possibly not. You probably went on price, performance, or something else. IBM estimates, each breach is 4.45 million. Heartbleed, there's big numbers, scary numbers. And we're also seeing the number of attacks on these low-end devices, microcontroller devices, increasing. So they're becoming more and more the target of interest because they're connected to the internet. Previously, they were not connected. Now you have things that are connected and everywhere, and they're a great way to attack. And so to make it relevant for this audience, hopefully some of you went out and enjoyed some of the opportunities. So we would prefer people to be spending money on interesting things rather than breaches and attacks. So So what is CHERI? So memory safety, memory integrity, memory bugs, it's a done problem, isn't it? It was fixed. We've got Rust, we've got other things. Well, Microsoft a few years ago, 6 years ago now, put a report, and this still roughly maintains, which is that 70% of the CVEs are still related to memory safety, memory integrity. So could you use Rust? Could you use .NET? Could you use memory safety languages? Well, yes, but you then have to try and fix all that old legacy code. Now, yes, you can go through that, but I don't think people are going to be spending time on that. So billions or trillions of lines of code. But also there's different levels of compartmentalization. So for new code, yes, absolutely. We support Rust, and we think that's still useful to do. CHERI and CHERIoT. So CHERI, as I said, is a 15-year-old sort of piece of work from Cambridge and SRI International, capability hardware enhanced RISC instructions. And what we're doing here is deterministic fine-grained protection. So I implore you, if you're interested in security, if you're interested in memory safety and memory integrity, people have mentioned in various talks about PMP, PMP. There's been MMUs, there's been various discussions. There is a lot of work on this, which goes, in the RISC-V space, you've got 64 PMP regions. This goes into really fine-grained resource management, so you can actually look at this, you can do sealing, compartmentalization. So this offers you a lot more. So think of a Chrome tab. Is your image that you're loading, has your image library been corrupted? Oh, that's resource. Well, then you can do a side channel attack and escape and do lots of other things. So this is a much finer-grained approach. And this gives the hardware an idea of what memory is about and what it's doing. So, this has been pushed forward. CHERI was worked on the ARM SoC, so there was a Morello board. And so that's a 64-bit platform. People have used that. But the thing is that it's quite hard to find. You can't buy it, and it's a little bit questionable on how ARM will continue with that support. In comes DSBD asking us, can we do this for the 32-bit microcontroller world? Can we show that CHERI is useful and is going to protect all this legacy code for embedded hardware, which is everywhere and pervasive? Microsoft have worked on this as well, and they took IBEX, which I mentioned, low-RISC NLP rates, and they've combined CHERI with Anatos, and I'll show that in the next slide, and they've pulled this together. So then we got CHERIoT, which is on the embedded side. So firstly, I just want to show quickly the board iteration. So I showed you the physical boards. We've had about a year, and we've gone through multiple, going through all the open source design. We've gone through this all, and now we have the products, and it's out there, and people have been using this. Some of the features, this is meant to be low-cost board. We don't make a profit on this. We give the boards with a very fine margin. We produce it. We give everything on here is Apache 2 licensed. You can download the PCB. You can download the bill of materials, Gerbers, etc. You can download it all. And there's various things here for experimenting with various things that you'll be familiar with Raspberry Pi, hats. You've got Arduino shields, so anything that you could connect to. We think we've got you covered on the embedded side. We don't, it's not PCI Express. It's not things on that side. But for low-speed controllers, which are still, vulnerable to attacks, various, less likely to get interest on memory safety, etc. We think this is the area that's useful. So lots of features here, which are good to play with. Block diagram to show how this all fits together. Essentially, it's low resource. So I mean, you're not going to be able to do AI mining, all these sorts of things which are interesting. This is really focused on that hardware that's going to be resource constrained. So it's all designed for that, And this just shows you the block diagram of that. And as I said, Microsoft took on IBEX and CHERI, put an RTOS with it, and we've got CHERIoT. So in the sake of time, I won't go too much into detail on here, but essentially people are interested in this, and open source has meant people have taken IBEX, they've taken the ideas, and they've recontributed this all in. Part of Sunburst project, which Sonata came out of, is also about teaching and disseminating this. So lots of events. We were at High Peak a couple of weeks ago, and this event. So we're trying to bring the word of CHERI. We're trying to say that this is useful, that you should be interested in this. So you will see us trying to promote this. You'll see other companies doing that. KiCad. So everything, as I mentioned, is open source, but we designed it initially in Altium. But what we wanted to do is get the full flow. So that included the design. So we're very happy to say that everything is now fully open. The only thing that you can't get is the FPGA design. If AMD want to discuss open sourcing that, please approach me. But everything else is being converted. And of course, with KiCad, there was a great talk earlier, all the great features coming up. But yeah, one of the things which is very useful is being able to visualize it, being able to explore with it. So hopefully you saw the KiCad talk earlier. Now, as I said, one of the things about proving hardware is going from design, verification, into actually having chips. So based on the success of Sonata and people using this, we've had an extension for the project. It's not very long in time, but we've been trying to work with our new partner, SCI Semi, and we're trying to get this taped out. So actual real chips that enable CHERI and CHERIoT to be investigated. So real silicon. And so we're aiming to push this all through, make it available. They're hoping to get chips through MPW through 2025. So we're very excited about this. And the other thing is, I think one of the talks on Open Hardware Foundation yesterday were mentioning why would you consider CV2 type low-end systems? Very good. This is very good for being able to do analysis. You know, very simple microcontrollers. You can do a lot of work on it. You can understand the flow. It's not doing all sorts of strange things which you get on more powerful devices. And so part of this, given the security concerns and the safety and integrity concerns, is actually doing formal verification. And we're very pleased that Professor Tom Mellon and the University of Oxford are helping with this, as well as University of Cambridge, on doing this formal verification. So quickly into CHERI Alliance. So one of the things we said is about promoting this. CHERI Alliance is something new. It's again non-profit, looking to try and promote CHERI. There's quite a few interesting partners there. So if you haven't heard of CHERI before today, I hope you take away that this is something quite interesting and relevant. CHERI Alliance and open source. So idea is to try and get everything out using open source methodologies. We saw the benefits of Microsoft coming back, taking IBEX. It's all virtuous cycles. And if you are an individual, you can sign up for free. If you're a university and non-profit, it's also possible to work on joining for free as well. So if you want to talk about CHERI Alliance, please just speak afterwards as well. So there's lots of work on trying to get this through, also working with RISC-V to try and get this adopted as part of the standardization flow. And the great thing about this is that these boards, unlike the Morello platform, you can actually buy them. I haven't been able to bring any to sell because otherwise I'll get in trouble with customs, etc. Yeah, you can buy them on Mauser. This is a great way for experimenting with CHERIoT and being able to explore what is going to be adopted for memory safety and memory integrity. So there's a link there, and there's also going to be a link on the final slide. So, so basically there's lots of references, lots of information, and I do implore people to investigate it, find out about CHERI Alliance, find out about lowRISC and Sunburst and the works we're doing. So with that, thank you.
some questions.
Hi, so thank you for the talk and the great work. Especially I found the documentation, the website very thorough and lot of work being put in there. So great work. I just wanted to ask you about the tape out that would happen. Do you believe that taped out SOC that would be there would also be available for public like this project?
Thank you for the question. So first there was a comment on thank you for the documentation and thank you for the supporting material. We appreciate that. We spend a lot of effort on trying to get good DV and verification. There was a question on the SOC, whether that would be fully open source. Now, unfortunately, there are some bits of that which will be patented. There'll be certain things. We are verifying the open source part of that, and as part of that, we are trying to get the Sunburst chip repo open sourced. So it will be a doppelganger, so it will vaguely resemble the things, but there will be some other proprietary elements. Given the security interested in this, we would love to have it fully open source, but through our partners in SCI Semi, we're trying to encourage them to open source as much as possible, but yeah.
And sell the SOC also to us.
Oh yeah, and the thing is about selling the SoC. So yes, I think that they'll be willing, so that they're going to be doing mass market and they'll be wanting to sell the SoC.
How do you manage secrets like private keys and other things in an open source RTL?
The question was, how do you manage secrets? Now, on an open source RTL. Now, for that, I won't speak about this board, which doesn't have as much secure SCA and FI work. We believe in CHERIoT's principle, which is keep the secret secret and keep and everything else open. So what we do is we say that, so talking about Open Titan, that you maintain the secrets using OTP, fuses, you work on making sure that that part is kept secret. That's the only bit of the design that it's just that secret. Everything else is open. So there are some analog items and some aspects of the foundry that will be proprietary.
Hello, thank you for your presentation. Just a little more detail about the tape out. Will it be an open source PDK, an open source design flow?
Yeah. So the question was, will we be using an open source PDK? Will we be supporting the flow fully through open source? Unfortunately, as you saw, it was 22 nanometer FDX SOI, which is proprietary. Unfortunately, I would love to have the whole design in in an MPW and being able to experiment with it. Unfortunately, for various reasons, it's going to be at that node size. So I'd love to come back in a year or two's time and say, yes, it's all going to be in the open flow.
Any more questions?
If there's no more questions, we have some leaflets, some flyers, and some swag and things. So just please feel free to approach me just outside, and I'll give some of that out.
Yeah, John will be just outside. Thank you again, John. So as you come into the dev room, please do try to squeeze into the center so that we get